Welcome to today's video. In this video, we are going to introduce you to one of the most important devices in modern industrial automation, the Programmable Logic Controller or PLC. Whether you're working in manufacturing, robotics or any automated system, understanding PLC is key. So, let's dive in and break it down. PLC is a digital computer that's designed to control industrial processes or machines. It replaces traditional hardwired relay-based systems and allows for more flexibility, reliability, and easier control of complex processes. In simpler terms, a PLC acts as the brain of a machine or system, receiving input, processing it, and then sending out commands to control different parts of a process, all based on pre-programmed logic. Now let's take a look at the main components of a PLC. A typical PLC has three main parts. First, the central processing unit CPU. This is the brain of the PLC, where all the logic and processing takes place. Second, the input and output modules. These modules allow the PLC to interact with the outside world. The inputs are signals from sensors or switches, while the outputs are signals sent to control devices like motors, lights or valves. Finally, the power supply provides the necessary power to run the PLC and its components. So how does a PLC actually work? Let's break it down into a simple flow. First, the PLC receives inputs from sensors or switches in a system. These inputs could be anything from a temperature reading to a button press. Next, the PLC processes this information based on pre-programmed logic. It uses a set of instructions like a recipe that you can write using programming languages such as ladder logic or structured text. Finally, the PLC sends output signals to control devices like turning on a motor, opening a valve, or activating an alarm. These actions are based on the input data and the logic it was programmed to follow. In this way, the PLC continuously monitors inputs, makes decisions based on those inputs, and triggers outputs, ensuring processes run smoothly and efficiently. Let's look at a real-world example. Imagine a production line with a conveyor belt. The PLC is responsible for controlling the movement of the belt, checking for any items on it, and triggering other machines to perform actions like packaging or labeling. Here, the PLC receives input from sensors on the conveyor belt to detect when an item arrives. Based on the data, it sends an output signal to start or stop the belt or to trigger a robotic arm to pick up the item. To sum it up, a PLC is a powerful tool that controls industrial processes through automation, making systems more reliable and efficient. Whether you're looking to automate a small machine or an entire factory, the PLC is a fundamental technology. If you're interested in learning more about PLCs, mechanical systems, automotive tech, or any of the other topics we cover, don't forget to subscribe and check out our upcoming videos. Thanks for watching and see you in the next video.